Hey everyone, and welcome to this explainer. Look, today we're going to completely transform the way you write code using AI. Seriously, if you've ever spent way more time fixing AI-generated code than you would have spent just, writing it yourself from scratch, you're in the right place. We're looking at a pretty brilliant strategy from Troiana's AI Hub that shifts you from just crossing your fingers and hoping the AI gets it right to virtually guaranteeing that it does. So, let's jump right in.
Okay, let's dive into this. It's kind of the universal frustration of modern development, right? You give your AI a prompt, hit enter, and out pops a block of code that looks amazing at first glance. But then you look a little closer and it's drifted. It's making wild assumptions. It's solving a problem you didn't actually ask it to solve. So why does this happen? Well, it's because we're forcing the AI to play a guessing game with our intent. We absolutely need a way to just completely remove that guesswork.
Section 1. Spec-First Code Generation. So the crucial point is, this isn't just a minor prompt hack or some quick tip to memorize. It's actually a completely new mental model. You kind of have to stop acting like a user just typing into a chatbot and start acting more like a strict engineering lead delegating a very precise task. Spec-First Generation basically means handing the AI the exact boundaries of the problem. You give it the function signature, you toss in a couple of concrete input and output examples, and you tell it, hey, fill in the body. You completely stop describing what you want it to do in vague prose. No more writing paragraphs about how the code should feel or behave. You just define the exact borders.
Section 2. The unambiguous contract.
Setting up this unambiguous contract is actually an incredibly simple, repeatable workflow for literally any developer. Here's how it goes. Step 1, provide the exact signature. Step 2, provide the example inputs and outputs. And step 3, ChatGPT, or whatever your AI of choice is, fills in the body of the function. And step 4, you run the test. That's it. You give it the contract, you give it the test, and you just let the AI do its thing and fill in the middle. It takes all the heavy lifting off your plate, but totally leaves you in the driver's seat.
And this idea right here brilliantly illustrates why the method is so powerful. A signature plus examples is an unambiguous contract. By giving it those examples, you aren't just explaining the logic to the AI, you're actually simultaneously writing tests that you can run right away. The AI's output is instantly verifiable. It either passes the contract or it doesn't. No gray area.
Section 3. The Slugify example. Let's move to and see how this builds.
It's one thing to talk about contracts in theory, but let's see exactly what this looks like in a real code editor with a classic developer task, building a Slugifier. Now, we all fall into this bad habit of using vague prose, like make a web-friendly title. If you prompt like that, who knows what you'll get? The AI might replace spaces with dashes, or maybe underscores. Maybe it keeps capital letters, maybe not. But look at the concrete spec. You define Slugify as taking a string and returning a string, accompanied by two very, very clear examples of what the output should actually look like.
And because you set up that strict contract, the result is completely flawless. The AI looks at your examples and deduces exactly what the body needs to do. It realizes, oh, I need to strip out the punctuation, collapse the extra spaces, and force everything to lowercase. It writes the exact logic required, and because you already gave it the examples, well, it passes them on the very first run. Literally zero back and forth required. It's almost like magic, but really, it's just good engineering.
Section 4. When to use it.
Now, knowing exactly when to deploy this tool is honestly just as important as knowing how it works. You absolutely want to use this technique for self-contained functions where you already know the interface. Like, you know exactly what needs to go in and you know what needs to come out. On the flip side, you should skip this technique when the interface design itself is the hard part. I mean, if you don't even know what shape the data should take yet, you got to design that first. And hey, if you just need a quick throwaway one-liner, those prose-only prompts are still perfectly fine for that.
The absolute ideal use cases here are things like parsers, formatters, data validators, and small transformations. Basically, whenever you have a task where you can confidently state at least one concrete input and its expected output, you should definitely be using Spec-First Generation. It takes these tedious, hyper-precise tasks and turns them into a 5-second automated job.
Section 5. Avoiding common mistakes. Now, what's really interesting here is how this highlights our own bad habits. Even when we try to be precise, we often manage to shoot ourselves in the foot. So let's look at a few pitfalls you absolutely need to avoid. First, big mistake: describing behavior with adjectives. Telling an AI to make it robust or make it clean. That means absolutely nothing to a machine.
Just show it the input and output. Second mistake, and this one is wonderfully ironic, is accepting the AI's generated code without actually running the very example tests you just provided to it. Come on, run the tests. And finally, the third mistake, bundling 5 different functions into a single prompt.
I really want to double down on that last point. When you bundle 5 functions into one giant prompt, you are completely breaking that clear contract. If something goes wrong, you have no idea which spec produced which bug. The entire point of this system is clarity and isolation. So you really have to generate code in small, distinct units rather than, trying to build a whole app in one go. Keep it modular.
Section 6. Advanced Test-Driven Loops.
Okay, so you've got the basics down. Now, let's take this basic concept and level it up into a highly professional engineering loop. This is where the AI graduates from just being a simple code generator to a true pair programming partner. This essentially mirrors a real test-driven development, or TDD loop. Step 1, you add a failing test as your example. Step 2, you ask the AI to make that specific test pass. And here is the absolute genius. Step 3, once it passes, you ask the AI to add 2 edge cases that it thinks you might have forgot to consider. You're actually forcing the AI to critically analyze the boundaries of the contract you just wrote together. It's a total game changer.
To completely round out this new toolkit, there are a couple of related best practices from the Troiana source to keep in your back pocket. First off, explicitly ask the AI for the tests alongside the code it generates. Don't let it just give you the code. And second, make sure you give it your technology stack and your coding conventions right up front. The less the AI has to guess about your specific environment, the tighter and way more accurate its code generation is going to be.
Think about the last time you asked an AI to write code for you. Were you just crossing your fingers and hoping for the best? Probably, right? But by shifting to a spec-first approach, using those strict signatures and concrete examples, you completely take the power back. So I'll leave you with this thought. Are your vague prompting habits actually holding your codebase back? It's time to stop describing and start specifying. Thanks for joining me on this explainer, and happy coding.